This is Mr. Anderson for Keller Community College, and we're today going to look at Part 12 of the Final Exam Review. Look at two-story problems and a problem dealing with a quadratic-ish graph. It's going to make a parabola, but this is in the vertex form, and the vertex form is pretty easy to actually see the vertex. Now, my suggestion would be to type this into the calculator. And I've got a calculator here. Let me bring that up. Okay, so let's see where I'm going to put this here. Boy, I guess I'm gonna kind of use the screen here, and then I'll kind of move it down to the bottom. Click on your y equals and type in the equation that you see here. Make sure you use a negative instead of a minus sign. That is a common mistake that people do, and your calculator will allow you to type it in and not, let you know about it until you try graphing it. Because if you hit the minus sign there, it'll say syntax error, and many students during the test will not be able to find where that mistake is. But it really is a negative, and this is what the graph looks like. Now, obviously, you're going to need to plot some nice points for that. So let's go and take a look at the table here. And I'm going to kind of balance this out here table-wise so it looks a little bit nice and symmetric. And I'll freeze this here and then kind of go and answer the questions that are on the test here. Okay, so it looks like we have a point at 5, 2. So let's move 1, 2, 3, 4, 5, and up 2. We got a point at 4, -1, and there's a point there, and 6, -1. Okay, so here is our parabola. Now we're going to try to graph 5 nice points, but if you can only graph 3, then that's okay. So we're done graphing. We're going to state the vertex, which is the point at 5, 2. All right, done there. State the axis of symmetry. This has a vertical axis of symmetry. The axis of symmetry is the line where x is equal to 5. It has to be stated as an axis or a line like that. And state the maximum. The maximum, let's see, you get to choose max or min. This definitely has a maximum. This is a maximum right there. It's no higher than this dotted line going across. So that max is going to be at y equals 2. And again, sometimes they only want you, some professors only want you to say just max or min, but this is a maximum at y equals 2 if you have to go that far. All right, let's go take a look. Let me push this away here. Pow. All right, let's go take a look at a distance equals rate times time problem. All right, so this next problem here, we have the current in a typical Mississippi River shipping route flows at a rate of 4. Hey, wait a second. This story problem looks like a dirt problem. And dirt problems are set up on a 3x3 little grid. And the 3x3 grid, the first row of it is always going to be the same. The first row is going to be distance equals rate times time. The distance, it says now, in order for a barge to travel 24 miles upriver and then return, so we're looking at 24 miles upriver and then 24 miles back downriver. Approximately how fast must the barge be able to travel in still water? Well, let's kind of go through here. The rate, if we're going to go upriver and the water flows at a rate of 4 miles an hour, so going upriver, we're going to be x minus 4 times some time. Like, we don't know how long it's going to take, but it's going to be a little bit longer than when we're going downriver, where it's going to be x plus 4. The river is going to give us a boost in speed. And our T1 and T2 are different times, but they will add up to a round trip of a total of 5 hours. So if I can get each of these expressions written in terms of T1 and T2, I should be able to get my equation up here and then solve for x. So as I set up my table, my second instruction would be is that you write the equations. So the first equation would be 24 is equal to r times t, which is x minus 4 in parentheses times t sub 1. Use the parentheses there because it's going to come in handy. Then I got my 24 is equal to x plus 4 times t sub 2. Now here's what we're going to do. We're going to divide both sides by x minus 4 and x plus 4. So I'm going to rewrite this equation in terms of t sub 1 all by itself now, where 24, let's see, yeah, it looks a little nicer. 24 is equal to over x minus 4 is equal to t sub 1. And my t sub 2, if I divide by x plus 4, this is 24 divided by x plus 4 is equal to t sub 2. Alright, so what we're about to do here is we're about to add t sub 1 plus t sub 2 is equal to 5. So let's go set it up. 24 over x minus 4 plus 24 over x plus 4 is equal to 5. Now to solve a problem like this, I'm going to have to clear the denominator. So I'm going to multiply by the lowest common denominator. In this case would be 2 parentheses, x minus 4, x plus 4, x minus 4, x plus 4, and then finally x plus 4 and x minus 4. It doesn't matter the order, right? So I'm going to cross out these x minus 4s, and I get 24 times x plus 4. I'm going to cross out these x plus 4s, and I'm going to have 24 times x minus 4. And then I'm going to have 5 times the quantity of x squared minus 16. And the reason why I did that is because this difference of squares can be FOILed and simplified to x squared minus 16. So if I do all my distribution down here, now I have 24x plus 96 plus 24x minus 96, and then we are going to set that equal to 5x squared minus 80. Now these 96's are opposites, so they will simplify. I'm going to move the 24's over to this side, so now I have 5x squared, let's see here, minus 48x minus 80. So now I have my equation, and I'm not going to try factoring it. I'm going to use the quadratic formula. So this is going to be my a is 5, my b is negative 48, and my c is negative 80. So I got 48, that's my negative b, plus the square root. Now normally we go plus minus, but you'll see that the negative value makes an impossible answer. In this case, a negative x value, which doesn't make any sense since we're not driving in reverse. So we're going to ignore it there, and we can do so most of the time when the a is positive as well. So negative 48 squared minus 4 times 5 times negative 80. Sorry that the writing is getting a little small here. All divided by 2 times 5. So what I have here is 48 plus the square root of 3,904 divided by 10. Now if you add this up, 48 plus the square root of 3,904, and hit enter and then divide it by 10, you get an answer that's approximately 10.9 or 11 if you round it up. So your answer for the problem is going to be approximately 11 miles an hour. Again, if you round it up to, because it's like a 10.99 something. So that would be the answer for problem 52. And again, we only use the plus value of this answer, because if we use the minus, you would see we get a negative value for x. Alright, so for our last problem here, even though this problem is slated in this chapter here, this actually takes us back to chapter 6. It's kind of a little callback here because it's a work problem. Goods Candies of Indiana makes all their chocolates by hand. It takes Ann 10 minutes to make a tray of candies and chocolate, and it takes Clay 12 minutes. So working together, how long does it take? Now this is a work equation, and you can tell that two people are going together to make one project. So work equations are set up like two fractions equaling 1. But now here comes the question. What goes where? The numerators are always how long it would take both of them to finish the project. And since we don't know that, that's going to go in the numerator. The denominators, though, are going to be what their individual times are, so 10 and 12. So this is Ann, and this is Clay. So what we're now going to do is solve for x. And the only way to do that is by clearing the denominators and then solving for each x, or for the x when we combine them. Now you could get a common denominator of 60, or just use 120. What this means is that you're going to multiply everything in this list by 120. Now this is clearing the denominator because 120 divided by 10 is 12x, or 12 times x. And this is 120 divided by 12, which is 10x, and that's 120 right here. This is 22x is equal to 120. Divide both sides by 22, and the x is equal to approximately 5.45 minutes. It repeats, but we're going to just say about 5.45 minutes for this problem. Now there is, on the very, very last page of the last video that we do, another one of these work problems where it's going to be set up quite differently. So just be prepared to see that at the end of the video, and I thank you for watching.